Beyond the corridor of our space-time, there are infinite numbers of universes. Each of them is governed by its own set of laws and physics. Laws and physics aren't you violating the built-in codes or the laws of physics? Which do you think is more valuable to humanity? A. Finding ways to tell humans that they have free will despite incontrovertible fact that their actions are completely dictated by the laws of physics as instantiated in our bodies, brains, and environments that is engaging in on our philosophical practice of showing that our notion of free will can be compatible with determinism, or B, telling people based on our scientific knowledge of physics, neurology, and behavior that our actions are predetermined rather than dictated by some ghost in our brains, and then sussing out the consequences of that conclusion and applying them to society. Of course, the answer is B. I can't tell if you're reciting Newton's first law of physics is the hottest thing to date, or if it makes you more intimidating. It may be appropriate to quote a statement of Poincare, who said partly in jest, no doubt. There must be something mysterious about the normal law, since mathematicians think it is a law of nature, whereas physicists are convinced that it is a mathematical theorem. The more important and fundamental laws and facts of physical science have all been discovered, and these are now so firmly established that the possibility of their ever being supplanted in a consequence of new discoveries is exceedingly remote. Nevertheless, it has been found that there are apparent exceptions to most of these laws, and this is particularly true when the observations are pushed to a limit, i.e., whenever the circumstances of the experiment are such that extreme cases can't be examined. Such examination, contamination, annihilation, equation, invasion almost certainly leads not to the overthrow of the law, but to the discovery of other facts and laws whose action produces the apparent exceptions. As instances of such discoveries, which are in most cases due to the increase in order of accuracy made possible by improvements in measuring instruments, may be mentioned. First, the departure of actual gases from the simple laws of the so-called perfect gas, one of the practical results being the liquefaction of air and all known gases. The second, the discovery of the velocity of light by astronomical means, dependent on the accuracy of telescopes and of astronomical clocks. Third, the determination of distances of stars and orbits of double stars, which depend on measurements of the order of accuracy of 1/10 of a second angle, which may be represented as that which a pen's head subtends at the distance of a mile. But perhaps the most striking of such instances are the discovery of a new planet of observations of the small irregularities noticed by in the motions of the planet. Uranus, when starts been rap hiatus, where it goes inside of my head, echoing again. I said, there's a spit rapping again and again. Mathematics is a language plus reasoning. It is like a language plus logic. Mathematics is a tool for reasoning. It is impossible to explain honestly the beauties of the laws of nature in a way that people can't feel without their having some deep understanding of mathematics. I am sorry, but this seems to be the case for those who want some proof that physicists are human. The proof is in the idiocy put in of all the different units which they are used for measuring energy. I'm going to tell you what nature behaves like. If you will simply admit that maybe she does behave like this, you will find her a delightful and entrancing thing. Do not keep saying to yourself that you can possibly avoid it. But how can it be like that? Rap, spat, because you will get down at the drain into a blind alley from which nobody has yet escaped. Nobody knows how it can be like that. Electrons, when they were first discovered, behaved exactly like particles or boltlets. Very simply, research showed from electron diffraction, diffraction experiments, for example, of that razzle-dazzle purple snapple, that they behaved like waves. As time went on, there was a growing confusion about how now brown cow these things really behaved. Waves of particles or waves. Everything looked like both. The growing confusion was resolved in 1925 or 1926 with the advent of the correct equations for quantum mechanics. Now we know how the electrons and light behave but what can I call it? If I say that they behave like particles, I give the wrong impression. Also, if I say they behave like waves, they behave in their own inimitable way, which technically could be called a quantum mechanical way. Behave all night and all day, away goes the day. They behave in a way that is like nothing that you have seen before. Your experience of things they have seen before is incomplete, obsolete. The behavior of things on a very tiny scale is simply different. An atom does not behave like a weight hanging on a spring and oscillating, nor does it behave like a miniature representation of a solar system with little planets going around in orbits, nor does it appear to be somewhat like a cloud or fog of some sort surrounding a nucleus. It behaves like nothing you have seen before. There is one simplification. At least electrons behave in this respect in exactly the same way as photons. They are both strictly but exactly in the same way. The different really is the psychological and exists in the perpetual torment that results from your saying to yourself, but how can it be like that? Rap, taking a nap. I fall over, I begin to take a nap. I drank too much, I'm gonna get stuff, rap, I gotta take a nap. In fact, the total amount that a physicist knows is very little. He has only to remember the rules to get him from one place to another. One way, another. I'm gonna get you. I'm gonna find you, get you. And he is all right, rhyme all night. I happen to know this, and I happen to know that. And maybe I know that, and I work with everything out from here, there, and funny places. Funny things are everywhere. Tomorrow I may I forgot that this is true, but remember that something else is true, so I can reconstruct it all again. I am never quite sure of where I am supposed to begin or where I am supposed to end. Just remember enough of all the time so that as the memory fades and some of the pieces fall into pieces, I can put the thing back together again every day. Suppose that physics, or rather nature, is considered analog to a great chess game with millions of pieces in it, and we are trying to discover the laws, breaking the law, by which the pieces move. The great gods who play this chess play it very rapidly, and it is hard to watch and difficult to see how we are catching on to some of the rules, and there are some rules which we can work out which do not require that we watch every move. For instance, suppose there is one bishop, only a red bishop on the board. Then since the bishop moves diagonally, horizontally, rectangly, triangle, circle, and therefore never changes the color of the square, if we look away for a moment while the gods play, and then look back again, we can expect that there will be still spitting a red bishop on the board, maybe in a different place but on the same color square. This is in the nature of a conversation law, about breaking the law. We do not need to watch the insides to know at least something about the game. A philosopher once said it is necessary for the very existence of science that the same conditions always produce the same result. On the other hand, in the case of hypnotism, at first it looked as though that also would be impossible when it was described, and completely not that it is known better and is realized that it is absolutely impossible that hypnosis could occur through normal physiological though as yet unknown processes. It does not obviously require some special new kind of force. Without discovering the law of physics is like trying to put together the pieces, following the pieces of a jigsaw puzzle. The angular momentum appears in two forms. One of them is angular momentum of motion, and the other is angular momentum in electric and magnetic fields. I appeal. There is angular momentum in the field around the magnet, although it does not appear as motion, and this it has the opposite sign to spin if. Conservation, annihilation, equation, decapitation. Conservation just means that it does not change. All physics is rooted in the motion of law. The belief that we live in an ordered universe that can't be understood by the application of rational reasoning. I suppose Galileo felt that the discovery of the fact that the laws of nature are not changed and are changed to scale was as important as his laws of motion, because they are both put together in the tone of two new sciences. By this time, you are probably convinced that all the laws of physics are symmetrical under any kind of change whatsoever. So now I will give you a few that do not work. The first one is change of scale. It is not true that if you build an apparatus and then I'm Spartacus, and then I built another one with every part made exactly the same, of the same kind of stuff, but twice as big. That it will work in exactly the same way. When I'm with you, yes, it's true. There are other conservation laws. They're not as interested as those I have described, and do not deal with exactly with the conversation of numbers. Suppose it is absurd that energy can be measured in calories and ergs, and electron volts and foot pounds, and BTUs and horsepower. I got the power, stop shower time, hours and kilowatt hours, all measuring exactly the same thing. It is like half the money in dollars, pounds, and so on. But unlike the economic situation where the ratio can change, these dopey things are an absolutely guaranteed proportion. If